I'm going to try this for the third time now. Hopefully it's the charm. In which I want to do modeling with sinusoidal functions with the phase shift. Here's a nice question. I mean, this is not too involved, and hopefully we'll be able to get her done in such a way that it won't mess things up. In any event, it asks for the coldest time of day. Well, if you look at a graph of a sine curve, sine function is, it starts at 0 and it kind of goes around, right? Okay, but now we want the coldest day. So really the coldest day is where this quantity here is going to be maximum. Well, sine is maximum when the sine of pi over 2 is the maximum. So what we can do is just set 2 pi times t plus 1 over 24 equal to pi over 2, and then we're just going to go boink, boink, and then what do we got? We got t plus 1 is equal to, and then we get a 4 down below, there's 2 goes underneath, and 24 up top. 24 divided by 4 is 6, so t should equal 5. So anyway, hopefully that will work. I think the key is to just show all the work on this paper, because it's been blanking everything out before. So let's put a 5 there. Let's go back and see. Yay, we got it right. So there we go. All right, let's try another one. Okay, here's another one. This one's the average temperature in Santiago, Chile, I guess. Anyways, the year is 365 days long. All right, so I'll let you read it. I don't read too good. All right. In any event, the form of our answer is going to look like the following. Okay, so now, because we're talking about phase shifts here, the phase shift is coming out of this part right there, and so we'll deal with that, but we can deal with everything else in the first place. Okay, we know that the difference between the high and the low, or the average between 29 and 14, rather. What do we get? Was that 43? Yeah, so 43 divided by 2 would be 21.5. So that's what our D is equal to. Okay, our A would be the amplitude, which would be the difference between D and the high, or the difference between the lows. But if it's 21.5 and the high is 29, that gives an amplitude of A equals, let's do the math on this real quick. It would be 7.5, right? Because 7.5 plus 21.5 would be 29. Okay, so we got our A. Now our B, we get our B because we know that the period is 365, so B times 365 has to equal 2 pi. So B is equal to 2 pi over 365. If you just think about it, if T, if I put a little T here, T, when it equals 365, they'll cancel, and I'm left with 2 pi, which is what we want, so that it'll repeat itself. So now we got to sink our teeth into what the value of C is. Okay, so we know that cosine, the graph of cosine, it has its maximum value at 0. So we got to make C such a thing that when T is 7, it's 0. Okay? So we could just to make it 0, obviously C would have to equal 7. Okay? Finally, we have to figure out the temperature on January 31st. So that'd be T, go back to my pen, T of 31, which would equal 7.5 times the cosine of 2 pi over 365 times T, sorry, not T, but let me just erase the, it would be 31 minus 7. So 31 minus... Okay, so now we want it when t is equal to 31. So I would have to put a 24 there because 31 minus 7 is 24. And then I have to put in my plus 21.5. And I'll pause it and hit the calculator and get a number. After plugging this in the calculator, I get that t of 31 is equal to 28.37. So we'll see how we did. Anyway, that's my answer. I don't know why it's not letting me do the check, but I'm going to just see if we did. I'm going to try something. I'm going to call the movie here, but I believe that that is correct.